Reese has a beehive. The number of bees in the beehive is decreasing. Reese counts the number of bees in the beehive at the start of week 5, and he counts the number of bees in the beehive at the start of week 7. So he's going to have to be pretty good at counting. Here are his results. In week 5 there are 1,200 bees, in week 7 there are 900 bees. Assuming that the population of bees is decreasing exponentially, how many bees were there at the start of week 2? So, decreasing exponentially means that, well, forget about the decreasing for a minute. Exponential change means that it's decreasing by the same factor each time, by each week. So what we're saying here is that 1,200 times something, I'll call it x, would be how many there would be at the end of week 6. Then 1,200 times x squared would be how many there would be at the end of week 7, and so on. So it's kind of a little bit like compound interest in that way. You're multiplying by the same each time. So I'm saying if it's decreasing exponentially, then 1,200 times x squared would equal 900, because we're timesing this by something to get how many there would be at the end of week 6, and then timesing it again to work out how much there'd be at the end of week 7, 900. We can then solve this equation to work out what x would be. So 900 divided by 12, we can then divide by square root, and we see that that is going to be root 3 over 2. I'm going to leave it in exact form for now. We could write that as a decimal, of course. So basically I'm saying that we're multiplying by this number each week to work out how many there will be in the following week. So therefore, if I want to know how many there'd be at the end of week 2, well, if I want to go backwards, I would have to divide by this number. So for example, if I did 1,200 divided by root 3 over 2, I can see that there would be 1,385.64 bees at the end of week 4. So I'm going backwards from week 5. This is how much there'd be at the end of week 4. If I then divide that again, this would then tell me how much there would be at the end of week 3. And then divide one more time to work out how much there would be at the end of week 2. So there we go. I'm going to say that there were 1,848 bees at the end of week 2. So the key thing there is knowing that exponential change means that you're multiplying by the same factor each time, which allows you to set this equation up. The rest of it follows pretty easily.